starting out Unit 3, Section 4.2, combining functions and composites of functions. So they give us some functions, and in the first couple of problems, they add us to do some operations with them. Either add them together, subtract them from each other, multiply them together, or divide them. That's what quotient is all about. So if they give you something like this, if they say f plus g of x, it's the same thing as saying, well, take whatever f of x was and just add it to g of x. So let's just kind of dive right in. But the very first thing you have to do is realize which functions they provide you. Would you all be cool with, here's the first function, f of x, and here's g of x. You need to look to see if there's any restrictions on their domain before you get started. What does that mean? It's like, is there any numbers that I could put in for x that just won't make it work? And here's the moral of the story. If there's any x's in the denominator, that could be a bad situation, because isn't the first commandment of mathematics, thou shalt not divide by 0? So for example, if I had, make up a new function, h of x equals 2 over x, there's one number that just x can't be in this function. What can't it be? So since there's x's in the denominator, that's a red flag, right? The other thing is if you have any kind of even root, like the square root of x or the fourth root of x or the sixth root, any kind of even root, because you can't take the square root of a negative number in the real number system, correct? So the domain of anything that's got an even root, you can take the square root of 0, right? And you can take the square root of a positive number, but there's no negatives allowed, so the domain of this guy is from 0 to infinity. Does that make sense to you? Right? If there's an even root, you just got to throw away all the negatives. So let's look at the functions provided and see what we could use for a domain. Let's look at the green one. Is there any x's in the denominator or any even roots of that puppy? What do you think? So that means all real numbers work for this domain right there. I put a double bar R above that, just letting myself know that in this green function, any value of x is possible. In the blue function, are there any x's in the denominator, or are there any even roots in this situation? Yes or no? So all real numbers are also possible. They gave me two functions to play with, the green one and the blue one, and every number works in either one of them. Awesome. They are now asking me to do this operation with them. They want me to add them together. So f is the green one. It's x cubed, correct? And they want me to add to it the blue one, which is g, which is x minus 1. So I got to take the green one plus the blue one. And I just look for any like terms that I can combine or anything like that. Are there any like terms, yes or no? Then they ask me for the domain of this new function. Whoops, my bad, shouldn't have done that. The domain of this new function. Again, you can only use what was provided for you in the beginning. You can only use all reals. Then you look at him and say, hey, is there anything messed up with this guy now? Are there any x's downstairs? Are there any even roots or anything like that? Anything messed up with this guy? So doesn't all reals work for him also? And they wanted an interval notation, so we'll say the domain is from negative infinity to positive infinity. Since we were allowed all reals in the first place, we just added these together and then looked at it, and we were still allowed all real numbers. Next one you have is subtract. So I got to take f of x, which is the green one, and subtract away the blue one. You should make that a whole quantity, because you got to subtract away the entire blue one. And then, of course, we have to distribute this negative through the parentheses to get it all cleaned up. So you'd get x squared minus x plus 1. Y'all cool with where that came from? Since all reals worked in both original functions, look at him, see if there's any x's downstairs or any even roots. There are not, so our domain is still all real numbers, which we write from negative infinity to positive infinity. Cool with that? Now on this one, they want us to multiply them together. So green one times the blue one. I want you to note there's a major difference. Give me a second here. Major difference between this symbol and this symbol. That is a dot. That is multiplication. This is an open circle, the composite deal, which we'll do later. Be very careful reading on my math lab. What did they want? Did they want the composite, or did they want you to multiply them together? Right? Closed dot, open dot situation. So they want us to multiply them together. I will do that. Do a little distributive property. X cubed times x is x to the fourth minus x cubed. Again, domain, I was allowed everything to start with. Now look at this. Am I still allowed everything? Yeah, there's no x's downstairs anymore, and there's no even roots. So we're still good with this new difference function. But now we run into a problem. I hope you realize domain's going to change here, because what do they want us to do with these functions? Divide them. We are going to have a denominator. We've got x cubed upstairs, because f is x cubed and he's upstairs. G is downstairs. G is x minus 1. But the whole thought process is, who was I allowed to use in the first place? All reals. Cool. Now in here, didn't we introduce an x in the denominator? Look at your entire denominator. He can't be 0. What value of x would make that turn out to be 0? So now we've got a problem. 1's a problem number, so our domain, with a pen, is everything but 1. So we go from negative infinity up to 1, not included, and then I union that with 1 to infinity. This right here means every number in the world except for 1. From negative infinity to 1, not included, union with 1 to infinity. Why is he a problem? Because that's downstairs. You can't have 0 in the denominator. You good with those? Next one, same concept. Add, subtract, multiply, divide. But the big trick to it is, look at your original functions and see if there's any restrictions in their domains. F of x equals square root of x. That's an even root. What are the only numbers allowed in this function? Starts with which one? 0 and goes to infinity. This guy originally only lets 0 or positive numbers work in him in the real number system. Cool? This guy, are there any x's in the denominator or any even roots or anything like that? So who's his domain? All reals. Which you can write negative infinity to positive infinity or the double bar r. It doesn't matter to me because that's not an answer. That's just helping me get to my point. But now when I add or subtract or multiply or divide, I'm only allowed to use the domain from what I could use originally. Here, all real numbers. Here, only positives. This guy trumps him, right? You're only allowed to use from 0 to infinity for your domain because it only works. That's all you're allowed to use here. So when you do any adding or subtracting, you can't just bring in somebody who doesn't work in the first place. So let's add them together. F is square root of x plus g, which is 1 minus x squared. There's nothing to simplify in that. Right? There's nothing to simplify because there's no like terms. Who's your domain? You're only allowed to pick from him in the first place, so I can only use this. Is there any further restrictions on that? Did we put any further x's in the denominator, or is there any more even roots or anything like that? We did do none of that, so the domain goes from 0 to infinity. You're only allowed to pick from who you were allowed from the very beginning. Subtract them, same concept, square root of x minus that whole quantity of 1 minus x squared. And then that'd be the square root of x minus 1 plus x squared when you distribute the negative through. Only allowed to use from 0 to infinity because this guy was restricted already. Nothing else came into play, so the domain is still from 0 to infinity. Awesome. Multiply them together. I need to take f of x, which is the square root of x, times 1 minus x squared as a quantity. And that gets messy if you try to distribute that. You'd want to change this to a rational exponent. I'd say just leave it like that. You know, this is good enough. Only allowed to pick from this domain. Did I bring in any more denominators with an x in it or anything like that? I did not. So my domain is still from 0 to infinity. And this is where things will change because we're dividing. F of x divided by g of x, 1 minus x squared. You already know you can only pick from 0 to infinity. Now we brought in a new bad guy, this guy. What values of x would make this turn out to be 0? If x was 1, This would be bad. What about if x was negative 1? What's negative 1 squared? 1, and then you'd get 1 minus 1, which is still 0. The question is, was negative 1 in our original domain in the first place? Could we even pick negative 1? No, because I could only pick 0 or positive numbers. So what I've got is my domain. Remember, we got to use him. We're starting at 0, which does count. And then isn't 1 the bad guy, right? So I go from 0 to 1, not included, and then I union that with everybody else who's positive from 1 to infinity. Negative 1 is also a bad guy, but he wasn't even in the original domain, so you don't care about him, right? So you could kind of say x couldn't equal 1 or negative 1, but that guy didn't even count in the first place, so he doesn't count in the second place either. And since you can only pick positive numbers, you got to just throw out the 1. Cool? These guys, how are they different? Number, right? Number, 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 instead of an x. So what we have to do is we have to evaluate f of 2, and then we have to evaluate g of 2, and then add them together. That'd be a mess if we didn't have this, right? This is going to make our life a whole lot easier. So here's what we will do. Let me minimize this for a second. Let's call f y1. Let's put him up here, and let's call g y2. And let's punch those guys into our calculator. F of x is x squared minus 5x, right? And g of x is 6 minus x cubed. You cool with that? I don't need to graph them. I don't care about graphing them, but I guess I skipped over something. We should have checked their original domains in the first place. So let's see if anything doesn't work in this guy. Are there x's downstairs or any even roots? Yes or no? This is an even power. The whole different deal. It's an even root. So real numbers work for him. And how about him? Do all reals work for him? So I'm allowed to select all real numbers out of both cases. Then what do I need to do? I need to evaluate these. I will let my table of values do all the work for me. What is the value that I am picking? 2 is my x value, correct? So I need to find where I have 2 for an x value, and then here's the f of x, or excuse me, here's f of 2, and here's g of 2, correct? You with me on that? So what I want you to do is just put a little bit of notes down. What was f of 2? It was negative 6. Is everyone down with where I got that from? What's the operation they want me to do? Plus, I will bring that down. What's g of 2? G of 2 is negative 2, right? Did I do that right? All you do is add them together. What's negative 6 and negative 2? Negative 8. All we're doing is evaluating f of 2, then evaluating g of 2, and adding them together. My calculator's table of values will do all of that for me. So now they want g of negative 1. So we got to watch the order. G is which guy? Y1 or Y2? G is Y2. So if I go to Y2, where x is negative 1, isn't g of negative 1 turn out to be 7? You with me on that? 7 minus f of negative 1, 6. And that final turns out to be 1. You cool with what I'm doing here? Then multiply them together. I need f of negative 2. So I got to move it up a little bit. F of negative 2 is 14 times g of negative 2, which is also 14. And you're supposed to multiply them together. So you get 196 when you do that. And finally, divide g of 3. G is y2, remember. Be very careful which one's which. Negative 21 over f of 3, which is negative 6. And first of all, negative over negative turns out to be positive. And then 21 and 6, doesn't 3 go in each one of those? So let's reduce it by 3. What would you get? 7/2. You cool with that? The number ones are the easy ones. Thank you, Mr. Calculator, so I didn't have to substitute all that stuff in and do all that work. Cool? So why don't you pause the video and get this one done here on number 4. Put those in, evaluate. A, 3 plus 2 is 5. B, 0 minus a minus 10, so it turns out to be plus 10, right, which is 10. C, negative 5 times negative 30 is 150. D, 10 divided by 0, how much? Undefined. Can't happen, man. Thou shalt not divide by 0. Sweet. Now we see composites. We see the open circle, correct? Open circle. So composite. H of f of x. Again, we need to go through our original functions and find any restrictions in their domains before we get going. So in f, is there any restrictions? X is in the denominator, any even roots, anything like that? He's all reals. G's, again, all reals. You cool with that? H, does H have any restrictions? X cannot equal 0, right? If you wanted to write negative infinity to 0, union 0 to infinity, this is not our answer right here. This is just helping us. And here's the rule on composites. Totally different than what we were doing before. We were doing operations, adding, subtracting, multiplying, dividing. Composites, the first function rules the roost. The first function rules. It's all about who comes first. The way you read the composite symbol out loud is following, H following F. Since H follows F, F comes first. It's like the exact opposite of what you think. It's listed second, but it comes first. You take the F function and put him into H. But the thing is, to look for restrictions, we have to look at F's original domain. Isn't F the function that comes, quote unquote, first? Who's his domain? All reals. Aren't we allowed to select any number we want to? Now, let's put him into H. So, whatever that is, you would say H of f of x equals, I need to take this guy, let me get a highlighter, and substitute him in for x into the H function. So what would it look like? 1 over, doesn't this go directly in for x right there? I would have 2x minus 5. I put f, isn't this red block f? I put it in for x into the H function. So, it's just straight substitution. Awesome. Now I need to write his domain. Okay. Was there any original restrictions? No. F was all reals. This is the function right here, correct? Is there any x's in the denominator now? Yes or no? So, I need to figure out what makes him 0. If I can pull this off to the side and figure out what makes him 0, wouldn't you add 5 to both sides? Divide by 2. What can x not equal? 5 halves. So I originally had all reals. Now, once I combine stuff together, I say, well, out of all reals, I still can't have 5 halves. So my domain goes from negative infinity up to 5 halves, united with 5 halves to infinity, non-inclusive. F allowed me anything I wanted. Once I put it into H, I had a problem because I put stuff downstairs. What was the problem? 5 halves. That's the problem. Let's try that again. Again, x can't equal 0. Everybody else is all reals. Who's the first function in this composite, f or g? G is my first function. Does he have any restrictions? Oh, no. He's all reals, correct? I need to put g into f is what I need to do. So this guy, pop, 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 goes in for x into the f function, right? I just do straight substitution. So this will equal, I'm going to copy him down, but wherever I see that x, I'm going to put 6 minus x squared in instead. This dude is the g function, correct? He went in for x. Then I clean him up a little bit. That would be 12 minus 2x squared minus 5, correct? And then combine my like terms. I like to put my x stuff first. So 12 minus 5 is positive 7, and that's got to be squared, sorry. Negative 2x squared. Then I look. Originally, I had no restrictions. In this guy, will I have any restrictions at all? No x's downstairs, no even roots, so the domain is still all reals. Why don't you try this guy for yourself right here? Pause the video, figure out who the first function is, are there any restrictions, then put him into the second function. F is the function that comes first. He's allowed all real numbers. Substituting in, this pink thing goes into the g function, so I put it in for x. Then you clean it up. This binomial has to get squared first. So you square the first guy, twice the product, square the last guy. There is a minus in front of there, so I distributed that through, and then I combined my like terms and got him. There were no restrictions in the first place. This guy also warrants no restrictions because there's no denominator with an x in it. So negative infinity to positive infinity is my domain. Yeah. Now, a little preview for next time. Let's find f of g of x, and then find g of f of x. So let's do our work shown like this. F of g of x. Who comes first? G. Let's put g into f. So this guy goes in for x into f. Y'all cool with that? So I would get 2 times 3x minus 1 minus 6. Then just work straight down. Just bring your equal sign down. That would be 6x minus 6, minus 2, my bad. Minus 6, 6x minus 8. That's what f of g of x is. Then I just kind of do another column right here. Let's do g of f of x. You do the exact opposite. Now you put f into g. So erase u, and this thing goes into the g function for x. So that would equal 3 times 2x minus 6 minus 1. This went in for x. Bring it down. Who is super smart and remembers if you get x back both times what those are when you do g of f of x and f of g of x? If this equaled x and that equaled x, anybody remember what those are called? Well, we'll find out on Monday. Let's do that again. F of g of x. This thing, got to take g, right? We'll take our time on this one because of the crazy fractions. He's got to go in for x into the f function. Y'all down with what we're supposed to do? It's going to get messy. So 3 times 2x minus 1 over 3 plus 1 all over 2. You cool with my substitution? It looked messy to start with. Now I look at that and say, hey, that ain't too bad at all. Because look at what I need to do. Take this green 3 times this blue thing, which has a divide by 3 in it. What's the times 3 and the divide by 3 do to each other? They're gone. So you're really left with 2x minus 1 plus 1 upstairs. Isn't that just plain old 2x upstairs? And it's over 2. And 2x over 2 is x. Ooh, we got x back. Do that again. Let's see if we get x back again. I need to go the other way around. I need to put this dog in for x here. 2 times 3x plus 1 all over 2 minus 1 all over 3 again. Fortunately, the times 2 and divide by 2 are there and cancel each other out. You're left with 3x plus 1 minus 1, which is 3x plus 0 over 3. That simplifies to x. Woo! So cool. That is awesome. Why? Tune in next time. Simple My Math Lab problems. The beauty of this is you can write over the top of your computer with the kind of computer you have, so it'll be even easier for you to deal with. It says use the graph of f and g to evaluate the functions. Same thing that we did on the front page, right? Kind of, sort of, maybe one time. First, you got to realize what are they asking you to do? Add, subtract, multiply, divide or composite, right? It just depends. So f plus g, they want me to add, of negative 4. Which one's f? Red one or blue one? Blue one. I need to find f of negative 4. What that means is use the blue function. Go to negative 4 on the x-axis, right here, and you put yourself a cool little dot there. Do you know what y turns out to be at that point right there? Y is 8. So isn't that really 8 in that situation? Plus g of negative 4. Don't you need to figure out what g of negative 4 is? Use the red function. Go to negative 4 on the x-axis and figure out what g of negative 4 is. What's the y value on the red guy when x is negative 4? It is how much? 2. And you add those together. And what's 8 plus 2? 10. This guy turns out to be 10. Now I want to slow down and realize what I did. I just did each one individually. I figured out f of negative 4, and I figured out g of negative 4, and I did the operation. When they give you operations, you just treat them separately every time. Cool? Part B is not an operation. It is a composite. Who do we do first, f or g? We got to do g. Let's figure out g of negative 3. So g of negative 3 is, if I go to negative 3, isn't that 1? Would you all agree with that? So this spit out 1. Then I have to take that and put it into the f function. So I do not evaluate f of negative 3. I must evaluate f of what? 1. Whatever this guy spit out. So I have to go to the blue guy and figure out what's f of 1. Well, I better go to 1 and figure that guy out. What's f of 1 turn out to be? 3. The composites are the weird ones. You got to figure one out before you can figure the other one out. You take what he spit out and put him into the other guy. Cool? Let's skip down to D real quick, because isn't that another composite guy? Who do you figure out first, G or F? So the final answer to that was 1, by the way. You with me on that? That was the final answer. We okay with that? Or was it 3? My bad. I did it backwards. It was 3. The first guy spit out a 1, then that result spit out a 3. That's your final answer. Yes, no, maybe? Again, let's do that on B. The composites are the goofy ones. Who do you figure out first, G of 3 or F of 3? F of 3. F of 3, let me erase all this cool stuff. That's the blue guy. Go to 3 on the x-axis. Follow him up. F of 3 is whatever this y value is. What is that y value? 5. So this guy spits out 5. Correct? Now I need to take 5 and put that into the g function. So I am now finding g of 5. So I go to the g function. I go to 5 on the x-axis and see where it touches the graph. And isn't that negative 7? That's my final answer. G of 5 is negative 7. Part C, not a composite. Plain old operation. Find f of 1. What's f of 1? F is the blue guy. What's f of 1 again? 3. Divide it by g of 1. G of 1 is negative 3. Y'all cool with that? And then 3 divided by negative 3 is negative 1. Operations, each dude use the same number both times. Right? You put f of 1 in, you put g of 1 in, and you just do the division operation. Here we did the addition operation. Composites, figure the first guy out, substitute that result into the next function. Whew. And finally, more profit and revenue and cost. Total weekly revenue is this function, and it is total weekly cost function for this camera is this guy, where x is the number of cameras that are produced and sold, which function is quadratic, and which function is linear. Let's start with C. What is C? Is he quadratic or is he linear? Because it's got an x squared in it, C is quadratic. Please spell it right. It's right there in front of your face. And R is this green function right here. Isn't it just got x's to the first power in it? That means he is linear. Form the profit function. Profit, again, equals revenue minus cost. Revenue is how much money you bring in. Cost is how much money that you spend, right? So you take your revenue and subtract away your cost. So profit equals revenue, which is 550x, minus the entire cost function, so you put it as a quantity, y'all cool with what I did there? Let's clean them up. Profit equals 550x minus 10,000 minus 30x minus x squared, because I distributed the negatives through the parentheses. Then I will combine like terms. Putting my x's first is the way I like to roll. It really doesn't matter. 550x and negative 30x is a positive 520x, correct? And then minus 10,000. Any questions on where that profit function came from? Is the profit function a linear function, a quadratic function, or neither? Look at the final black answer. What is he? Quadratic. Still got x squareds in it. And now it's time to say, no thanks, graphing calculator. Why waste your time? You will spend 10 minutes trying to find the vertex of this parabola using your graphing calculator. Is this in standard form? Yes or no? When they want the maximum profit and the maximum possible profit and all that stuff, right? How many cameras? What's the maximum? That's the vertex of this parabola. How do you find the x value of the vertex? Opposite of b over 2 times a. So x equals negative 520 over 2 times a, which is how much? Negative 2. What do you get? 260. That's the x value of the vertex. Pretend you made a graph of this situation. There are 2 labels that are dealing with. There is cameras and there is money. Who's on the x-axis, cameras or money? Cameras. Didn't we just find the x value of the vertex? They want to know how many cameras? Well, I'll bet it's 260 cameras. Gives the maximum profit. Find the maximum profit. Isn't that the dollar amount when you have 260 cameras made? Isn't that the y value of your vertex? Substitute that into parentheses, into that function. Put 260 in for x is all you have to do to find the vertex. Stop